Yo, how we doing today? We are going to finally use all this random stuff that it feels like we've been doing. We're finally going to kind of see why it is we've been learning all these different things. Why we've been doing this synthetic substitution stuff. Why we've been finding all these different roots. Today we're going to put it all together and kind of see why it is that we've been doing that stuff. So, rational zero theorem. What this says is that if you want to find some solutions to your random polynomial, something with an x cubed, x to the fourth, x to the fifth, whatever, all of the regular normal solutions are going to be of this type. They're going to be the factors of the constant, that's the back number that doesn't have an x on it, divided by all the factors of the leading coefficient, and that would be the front number multiplying by the big power. So if we had something like, I don't know, 4x squared, blah, 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 and then, plus 2, what we're going to look at is all the factors of this divided by this. And so we're going to look at how to do that first, and then how we're going to use that for all kinds of great, wonderful, amazing things. So here, rational zeros of this particular polynomial. First, we look at our back number, that's a 12. So what multiplies to make a 12? 1 times 12, 2 times 6, 3 times 4. And we can always use versions of pluses and minuses of them all, so we always write plus or minus. Then we divide it by the numbers in the front. Well, it's just a 1. Only one way to make a 1, and that's by multiplying ones. So, then we simplify things. It's nice with the 1 because everything divided by 1 just stays the same. So we just rewrite all those things, and those are all the possible answers to this particular. So, all it means is that of our 3 answers here, one of them is probably sitting in here if it's a nice normal rational number. So it's either a positive 1 or a negative 1. It's a positive 2 or a negative 2. What it does is this gives us choices of things that we can try out and see which one is the actual real solution. Alright, so what are all our possible zeros here going to be? Again, we take all of our multiples of 12 on the top. We take our multiples of the front number 2 on the bottom. This time, since we have 2 different numbers, we got to think about things a little bit. Over 1, we get our 1, we get our 2, 3, 4, 6, and 12. Now, so that kind of takes care of this guy. Now we've got to take all these top numbers and divide them by 2. Well, 1 over 2 is a 1/2. There it is. 2 over 2 is a 1. We already have that. 3 over 2 is 3/2, so there it goes. 4 over 2 is 2, already taken. 6 over 2 is 3, there. And 12 over 2 is 6, is there. So sometimes, especially when we get this second number here, we're going to get kind of doubles of the same numbers over and over again. It's okay. We just list them all out once. So the 2 down here really just gave us these 2 choices, the 1/2 and the 3/2, because the rest all divided back into numbers that we already had anyway. So you take the number over 1, you just write them all out, and then you take your other ones and see what fractions are going to be left that are numbers you didn't already have existing. So back number is our 7, so we've got plus or minus 1 or plus or minus 7 on the top. Our bottom is going to be a 2, so that's plus or minus 1 and plus or minus 2. So, what are all of our different answers? Well, plus or minus 1 and plus or minus 7 are definitely going to be there because over 1, 1 over 1, and 7 over 1. Now we got to look at our fractions. 1 over 2 is going to leave us a plus or minus 1/2, and then 7 over 2 is going to be plus or minus 7/2. And so these are not the actual answers, these are all the possibilities for regular, normal, rational answers. Again here. What makes an 8? Plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. All over. Plus or minus 1 and plus or minus 2. So, what do we have here? Our actual answers. We've got the 1, the 2, the 4, the 8, and now we've got to worry about what goes on with the 2. 1 over 2 is going to give us a 1/2. 2 over 2 is a 1 that we already have. 4 over 2 is a 2 we already have. And 8 over 2 is a 4 that we already have. So, that's it. Alright, last one here. We've got this guy and this guy. What makes a 27? A 1 does, what is it, 3 times 9? And the 27 itself. all over, 1 or 3. Am I missing any? Nah, I think that's it. Alright, so again, our actual possibilities, plus or minus 1, 3, 9, and 27. Now we got to worry about our over 3's. 1 over 3 is definitely going to be there. 3 over 3 is a 1, got it. 9 over 3 is a 3, got it. 27 over 3 is 9, got it. So that's it. All of our possibilities. Alright, which one of these choices over here is not a possibility? So let's think about it. We got plus or minus 1, plus or minus 2 on top. The 6 on the bottom is going to be a lot more possibilities. 2, 3, and 6. Alright, so now we just got to decide which one of these over here is not something that's going to get made by these. Can we make it 2? Yeah, 2 over 1. So that gets made. 2 over 3, right there, got it. 1/2, 1 over 2 is there. 3 though, there's no 3 on top to give me a 3 over 1. So that one is the one that is not, I repeat, not a possible answer because there is no 3 on the top. So we're not going to make a -3. Alright, and all of this mess all leads to this. Hey, when we got this random x cubed whatever type polynomial, now we finally have the tools to go ahead and solve and find all of its zeros, and then we can even graph that thing now with some pretty decent accuracy as to what's going on with our graphs. So what we're going to do, we're going to use what we just talked about to list out all of our possibilities. We're going to pick those numbers and use our synthetic substitution. That's the thing where we got the number out here and we do the whole zigzaggy thing. We're going to do that to find out which ones actually work. As soon as we get one with a remainder of 0, that's a factor. We're going to pull that out and then use our answer. And if we can factor the answer, we're going to do that. If we can't figure it out real easy, then what we're going to do to find those other roots is to use our -b plus or minus square b squared minus 4ac all over 2a thing, because this doesn't go away either. But if you don't like it, sometimes you can get around having to use it, but most of the time you're going to have to. So let's take care of this one here. What are our possibilities for answers? We get plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. All over, just a 1 in the front makes it easy on us, right? So now our choices, we got a 1, a 2, a 3, and a 6. So we got to start somewhere. I'm going to check 1. What we're going to do is we're just going to see, does 1 work? 1, oh, they're trying to get tricky here. There's no x squared term, so that's the 0, 0, minus 7, and 6. So we're going to do our synthetic substitution. We're going to check and see, is 1 one of our zeros? Alright, so the 1 comes down. 1 times 1 is 1, plus 0 is 1, 1 times 1 is 1, minus 6. Oh my goodness, look at this. 1 times -6 is minus 6, gives me 0. That is exactly what we're looking for. Make that into a happy face because we don't have to check a whole bunch of other answers. And honestly, I did not know 0 was going to work. Or 1 was going to work. I just picked it. So the positive 1, that is one of our answers. So what that means is that our factor then is not x plus 1, it's x minus 1. We're not going to get fooled on that. We just looked at that yesterday, right? So x minus 1 is one of our factors. The other thing that's left is going to be right here. X squared plus that x minus 6. Alright, look at that. Nice. We just factored out x minus 1 out of this x cubed thing. A week ago, you didn't think you were going to be doing that, did you? But maybe you're not, but you're watching me do it at least, and maybe you'll learn. So, now looking at this, I want to decide, is this something I can factor? Are there things that multiply to 6 that subtract and make that positive 1 in the middle? I hope you're thinking, heck yeah, x plus 3 and x minus 2. Look at that. Bam. And we just factored a cubic polynomial. Who'd have thought? So what are all the different solutions here? Well, we know this one gives us positive 1. This is going to give us -3, and this is going to get us positive 2. So those are our solutions. We just solved for x in a cubic. 1, -3, and 2 are all the 3 different solutions for our cubic polynomial. Man, that's nice. Alright, let's do this last one here. And then probably going to have to cut it off and go to another video, part 2. Alright, so doing the same thing we just did. We got our 10 in the back, so that's a plus or minus 1, 2, 5, or 10. All over 1 in the front makes life easy again, plus or minus 1. Alright, so let's try something. Maybe 1 works again. Let's try that 1. See if it's magical. 9 and negative 10. 1 times 1 is 1. Minus 3, 6. 6, oh, negative 4. Didn't work. That is not a possibility. So, when you kind of start doing these, you've got to make sure you keep track. So positive 1, no worky, means we cross it out. We want to check something else. What do you guys want to check? I don't know. It doesn't really matter, but hopefully we guess right. I'm going to try that negative 1 and see if maybe that's going to work for me. 1 minus 4, 9, negative 10. Minus 1 makes minus 5, makes positive 5, makes... Uh-oh, 14. This don't feel good. Minus 14. Nope, that didn't work either. So 1 is not fun for us. So let's try something else, maybe a 2. Now you're thinking, man, we really got to do all of this work. Yep, but imagine how hard this would be if you just had to plug them into the x's here. Not fun. Ooh, this is feeling a little better. I got a 5. 2 times 5 makes 10, gives me a 0. Happy face, because good times are here. Alright, so that's an x minus 2 times x squared minus 2x plus 5. So these 3 numbers here give me my 3 numbers for my new trinomial here. X minus 2 is the factor that I just found. So now I decide, anything multiplying to 5 that add or subtract to 2? No! And this is when you get to be a little bit sad. Now we've got to do our formula, negative b plus or minus that thing. So negative b is negative of negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 5 all over 2 times 1. Again, these numbers are all coming right here, a, b, and c. Bam, bam. Not from our original, from our new one here. So simplifying this stuff, what do we got going on? We got 4 minus 4 times 5 is 20. So we got a positive 2 plus or minus the square root of negative 16 all over 2. Hey, I know what the square root of 16 is. That's positive 2 plus or minus. Square root of 16 is 4, and since it's negative, we put an I on there all over 2. And I could sure cut both those numbers in half. Gives me 1 plus or minus 2i. So we've got those 2 answers plus our 2 here. So finally we write x equals 2 or 1 plus or minus the 2i. And those are our 3 solutions to this particular cubic polynomial. Alright. I think that's a good place to take a pause, and we'll take a look at video part 2 to check out those last couple of examples where we're going to do this process plus graph them. Because I know you were wondering, man, what do these graphs look like? Well, we're going to graph them, and it's going to be great. So make a good choice and go watch part 2.